Okay, for skill 19, we were told to find an ellipse or hyperbola with a focus at the origin, and then use that equation to make it into polar form. So the first thing we're going to need to do is make an ellipse with the focus at the origin. And to do that, I use this equation, x minus 15 squared over 289 plus y squared over 64 equals 1. So the first requirement was that our ellipse had to be at a 0, or our focus had to be at 0, 0. To ensure that was true, I had to make sure I had to use the c squared equals a squared minus b squared equation. And so using that, I can say that c squared equals, so a is the length of the semi-major axis, which is the square root of 289, which is, so we have to use 289. So a squared is 289, which we put below there. And minus 64. So c squared is 225. So square root of that, so c equals 15. So c is the length of the focus. So the length of the foci is 15. So we have to shift the whole equation either left or right to make one of the foci at 0, 0. I should just shift it to the right, which is why we have to have this x minus 15 in there. So that's our equation, and we know that it's in there. So we know that the focus is at the origin, is what I meant. So the next step was to make the polar equation. So we started with this parent function, which is r equals ek over 1 minus e cosine of theta, where e is the eccentricity. And then, so we can plug in the eccentricity, which we know because that's just c over a. And our c value, where we previously figured it out, was 15. And then our a value is the square root of that, which is 17. So we get 15 over 17 times k over 1 minus 15 over 17 cosine of theta. So then we have to figure something out to put in the angle and for r. So we know that when we're going at 180 degrees, the distance from the origin to our vertice is 2. So we can plug that into there. So after we do that, that's basically what we get. And then we know that cosine of 180 is just -1. So we can use that and plug and replace it with that. And when we simplify, we just get 1 plus 15 over 17. So what we're left with right now is 2 equals 15 over 17k over 1 plus 15 over 17. Then we can change the 1 plus 15 over 17 to equal 32 over 17. And to figure this out, we just got to flip and multiply, which is how we divide fractions. When we do that, we get 2 equals 15 over 32k. Multiply both sides by 32 to get 64 equals 15k. And then finally, we get that k is 64 over 15. So the top of our equation is ek, as we see up here. And then we can do e is 15 over 17, which is we determined previously. And k, which we just figured out, is 64 over 15. So what we're left with in the numerator is 64 over 17. So we have 64 over 17 over 1 minus 15 over 17 cosine theta as our equation. To simplify things and get rid of the denominators in each of the fractions, we can multiply by 17 over 17. So we'll get this canceled out and get this canceled out. So finally, we're left with r equals 64 over 17 minus 15 cosine theta.